In our previous videos, we've created a plant DTO, which represents a plant, and an interface for a DAO, or a data transfer object. In this video, we are going to look at making a unit test for our Android application. And what's nice about a unit test is it assures quality throughout the application because we can write a test that meets the requirements of the app. And then this test is automated. We can run it when we compile the app or at any time we choose. There are even things that will allow us to run the test automatically every time we save. Another nice thing is because we have very clearly separated our user interface layer, which is in this very first package, from our data access layer and our DTO layer, we can test the DAO and the DTO layers in isolation. In other words, we don't need to start the Android emulator to test these layers. And that's important. If you've done Android development or you've talked to people who have, one thing that tends to frustrate people is the emulator and how it tends to load slowly. So by separating things out into very distinct layers, UI, DAO, and DTO, we can actually test the DAO separately without actually starting the emulator. That's really nice. Now, this exercise we're doing is going to follow what I am giving you for the programming assignment. I am giving you a unit test that does not currently run, and your job is to make it run. So I'm showing you a little bit behind the scenes of what I did when I was making your homework assignment, your programming assignment. So to start a unit test, we need to make a new project. We're going to go to File, New, Project. Now, this is a unit test that can be used for Android. It has some specific things to help test Android programs. You even can write a unit test to test out the flows through your user interface. So what we need to do is select Android Test Project and choose Next. Excuse me. Now we choose a project name. We'll say Plant Places 14SS Advanced Test. That works. Okay, and this is falling off the screen a little bit, but down off screen I'm choosing Next. Okay, now here's the cool part. Which project do we want to test? It looks in my workspace and it sees what Android projects I have, and I can select one, and it automatically makes an association between those two projects. Choose a build target. We will stick with what is checked, and again, this is off screen, so I'll resize it so we can see it. Android 422, which is 19, which is, I want to say that's KitKat. KitKat, no, yeah, KitKat's 4.4, right? So we'll go ahead and choose Finish, and now it's going to create our project. Our project's been created. I'm going to expand. I'm going to go under Source, and you see it's created a package for us that ends in test. That's a fairly common paradigm. I'm going to right-click now, and this uses a JUnit testing framework, which is a very frequently used framework, a very well-known framework. There are two flavors of it. JUnit 3, where you would typically name a class that begins or ends with test, and JUnit 4, where you don't have to. We are going to, let's see, we're going to see what we have here. We're going to choose New, and then we are going to choose, we can choose JUnit test case. We'll try that. I think that's what I want, but I might want to do just a normal old class. We'll see here when it comes up. Okay. Test case. That's fine. Okay, we will call this one Plant DAO Test. There we go. Excuse me. And we'll choose Finish. Now, once we have our unit test, there's some methods that we can inherit from test case if we wish. I'm going to type SET, hold Control and hit space, and it will give us an overridden method called setup. This is something that will be run before any test. I'm going to go down and I'm going to type in TEAR, control space, teardown. This is a method that's run after any test. If you look right now, things are a little bit sloppy because our indentations are out of alignment. Luckily, that's very easy to fix in Eclipse. Control A, Control I will fix indentations. I don't have any setup or teardown I need to do yet, but we may get there. So what I'm going to do now is I'm going to test the fetch method. And the fetch method in our interface is called fetch, and it accepts a plant and returns a list of plants. So what I'm going to do is I'm going to say test fetch, which is normally in JUnit 3 the way we would name a method. In JUnit 4 we can call it whatever we want. We just have to add an @test attribute above it, that's all. But in JUnit 3 we're going to say test fetch. I'm going to say public void test fetch. And now what we're going to do is we can do some logic and we can do some assertions. If those assertions pass, our test passes. First of all, we need an instance of our DAO, don't we? So I'll make an attribute or a member variable, and I'm going to say I plant DAO, okay, like so. Control-Shift-O will organize imports, there we go, and that's fine. Now what we'll want to do maybe in the setup method is say plant DAO equals new plant DAO stub. Wait a minute now, we haven't even made a plant DAO stub, right? That's correct. So to get this test to pass, one of the prerequisites is we need to make a plant DAO stub. And when you get to the programming assignment, that's what you're going to find. You're going to find that I have created the interface for you. I have not created this implementation class, so that's one of the things you're going to need to do. Now let's go to test fetch, and I'm going to say plant DAO.fetch, okay? And we are going to want to fetch by some selection criteria, so let's figure out what that selection criteria should be. Let's say make a plant object that will serve as our selection criteria. Plant search plant equals new plant. Okay? Populate the common the common name attribute of this search criteria. And let me move this up a bit so we can see it in high def. Okay? So we're going to say search plant set common redbud. Okay. And Control-Shift-O organize imports and Control-S to save. Okay. Now we're calling plant DAO.fetch and we're passing in this search term. Fetch a plant that matches the given search criteria. Okay, plant DAO.fetch search plants looks pretty good to me. And we'll save. Okay. So, getting a red line here, let's see what it doesn't like. Unhandled type exception. Let's surround with try catch. Okay. Now, this shouldn't cause an exception, right? This should not cause an exception. So what we're going to do here is we're going to put in fail. That will automatically fail the unit test. If we reach that line, then we're going to consider the unit test to be a failure because we're not expecting an exception to happen here. If one does, the unit test will fail. We know we need to fix it. Now, plant DAO.fetch, that returns what? That returns a list of plants. So we want to save that into a local variable maybe. We know we can do that quickly by putting our cursor on plant DAO, or actually let's go over to the fetch method. Hold down Control and press 1, and we will assign statement to new local variable. And we'll say, we'll call it, I'll tell you what, we'll call it plants. So a collection of plants. So with Control 1, we're saying we told Eclipse to look at this method, see what it returns. Save that, we told Eclipse to figure it out and save that return value in a new variable, and then Eclipse automatically figured out the type for us. Now if you go to plantplaces.com, what you're going to find is that what you're going to find is that a redbud, the genus for redbud is Cercis, C-E-R-C-I-S. We will consider this a success if we get a result that contains Cercis. So what I'm going to do now is I'm going to iterate over the result, see if we have a Cercis genus. Okay, now there's a nice shortcut in Eclipse that will put together a for each loop quickly. No surprise, it's FORE, control space, for each. And take a look. FORE, control space, was smart enough to look at the most local, the closest collection, put that in an iteration, and then store that into a local plant variable that we can iterate over. Now, you could certainly type this out the old-fashioned way if you want, with for, space, and then the whole test. But the FORE shortcut in Eclipse just saves you a lot of typing. Either way, you're going to get the same result. You can certainly type this all yourself if you want, but that shortcut will save you a lot of typing. Okay? So, what we're going to do then is we're going to say, well, we want to make sure at least one of these has a genus called Cercis. There are several ways we could do this. What we could do is beforehand we could say Boolean contains Cercis genus equals false. So we'll assume false until we know otherwise. Okay, and then we can say if plant.getGenus dot equals, let's go ahead and say ignore case, Cercis, that's fine. Oh, I misspelled Boolean, didn't I? Then we're going to say contains Cercis genus equals true. Okay, and at that point, honestly, we no longer need to worry about the if test, or the loop, so we can just break out of it. No need to keep iterating. After the for loop was over, well, here, let me put a comment here. It says, we found a Cercis. After the for loop is over, we can say assert true contains Cercis. Okay? So if, contains Cercis genus. If Cercis genus is true, this assert true will, guess what, return true. If it's false, it will return false. If it returns true, our test passes. If it returns false, our test fails. So this is a simple JUnit test. We're just saying, if I give a search plant to my plant DAO stub, and that search plant has the common name genus, if I get back a Cercis, if the search plant has a common name redbud, and I get back a list of plants, and at least one of those plants has the genus called Cercis, we're going to consider this a success. Okay? So if I say search by redbud as a common name, and I get back a plant, and that plant has Cercis as the genus, then we have success. Now we just have to make it work. Well, we know it's not going to work right now because we have not defined what this stub is yet. Okay, and the stub is a good way to do a prototype. You know, we want to make sure we're doing what our stories are telling us to do. Remember, the product backlog in Scrum is the list of activities that we want to do, to add value to our product. So a lot of times we will work with users to come up with that list. And what we might want to do is make a little prototype and say, is this what you want? Take a look, is this what you want? Make sure that the user signs off on it. A stub is a good way to feel that out, to give the user an idea of what it's going to look like without actually doing all the SQLite work. So let's go ahead and make a stub. Okay, I'm going to go back to my main project, and again, in the DAO package, I am going to right-click, and I'm going to say New Class. Okay, and I'm going to call this class Plant DAO Stub. No surprise there. Superclass is fine. For the interface, I'm going to choose add, and I'm going to say iPlant DAO. There we go. By implementing that interface, oops, sorry, and then I choose finish. Finish is just off screen here, just a little bit. There we go. By implementing that interface, I'm under contract to implement all of the methods. And what you'll see here is that Eclipse was kind enough to just put those methods in my stub class with just empty implementations. Now, normally we should JavaDoc things, but remember we already JavaDoc the interface, so we're good there. Okay, Control M, make sure it's saved. Now let's go back to our test, and now that we have this class, let's see if we can get our test to compile. Control M. Okay, a little Control Shift O magic, and look, our test compiles. Control S, Control M. Let's run this now. Let's run this test. I'm going to right click. I'm going to say run as. I'm going to say Android JUnit test. This might take a moment to load, so I'll probably pause the recording. We'll sit back and relax for a moment as it loads. And what we're going to see next is the result of the unit test. I'm expecting it's going to fail because we've given it an empty fetch plants method. We haven't actually put anything in there yet, so it's not going to return a genus with a genus Cercis if we pass in a search criteria redbud. So this might take a moment to load. I'll go up. There we go. Nope, so it didn't take too long after all. Let's take a look. It shows us exactly which test failed. We can have multiple of these test methods, and to be honest, that's a very good idea, have a bunch of these test methods. So it's going to show us exactly which one failed, okay? And it's going to tell us why it failed. It says assertion failed error. It's going to take us to exactly the line number, and the line number was this exception, okay? We caught an exception because, let's take a look. We caught an exception because when we called this method, it returned an empty list, and then we tried to iterate over null. Okay, we tried to iterate over a null. That's not going to work. Okay, let's try again. So let's go to our plant DAO stub, and again, this is kind of what I want you to do for your assignment. For list plant, instead of returning null, let's go ahead and make an empty array list. So array list plant. Array list is a class that implements the interface list, so this is perfectly legal. All plants equals new array list plant. Okay, let's just return this empty list. Return all plants. Save, Control Shift O, organize imports. Save, Control M. Take us back to our menu. Package Explorer. Let's try to run the test again. So I right click, and once again we're going to choose run as Android JUnit test. Sit back and relax for a moment. I'll pause while we wait for the test to run. Now we see here the test still failed. The test still failed, which is no surprise because again we haven't given it a genus, or we haven't actually given any meaningful results. We've returned an empty array list. But what's interesting is it failed on a different location. Instead of failing on catching the exception, it has failed, let me Control M this a little bit, it failed on the assert true here. So it didn't find a result called genus. Okay? I'm sorry, a result called Cercis. So if I Control M again, if we look at the results, look at where it failed. It failed on the assert true. Okay, let's keep going. So I'm going to Control M. We're going to go back to plant DAO test. I'm sorry, we're going to go back to plant DAO stub. And now, again, we're just prototyping. We're not actually persisting anything, we're just prototyping. So what I'm going to do is I'm going to say if search plant, and remember, I'm in our actual, I'm not in the test right now, I'm in our stub. If search plant dot get common equals ignore case, and we'll say redbud, okay, and close with a double quote. Now what we're going to do is say plant p equals new plant, whoops, missed my friends there, p dot set genus Cercis, p dot set species canadensis p.setCommon redbud. And there we go. Now this looks kind of silly because we've just hard-coded it, right? But remember, what we're doing is we're proving out our test. And we're proving out our test without doing any heavy lifting on the SQLite side. What's nice is once we get a truly populated SQLite database, we should still be able to run this test against that SQLite database, and we should get similar results, okay? All we need to do when we run it against the SQLite database is replace this constructor call. Instead of plant DAO stub, we'll make it something like plant DAO or plant DBDAO or plant DAO impl. We'll make it the actual implementation class. So, test first design. Test first design means we want to design the test first and have the test represent the success criteria. Then we want to run the test against production code and make sure that the test pass. Once the test pass, this unit of work is complete. So the test should be very thorough. So here we have test fetch. Okay, this time I'm feeling pretty confident. Not 100%, you never know, maybe I made a mistake. But let's go ahead and run this test yet one more time and see what happens when we do get a genus of Cercis when we pass in a common name of redbud. So we're going to run as Android JUnit test. Sit back and relax one more time. And we'll start thinking about some other tests we can write. Maybe we can write a test on save so that we can make sure if we pass in good data, we don't get an exception. If we pass in bad data, we do get an exception. Okay, I'll pause as this runs. It might take just a few more moments. Well, to my surprise, it failed. We have what we can do when it does fail, though. And what we can do is we can debug. So I'm going to right-click. I'm going to choose Toggle Breakpoint. And we're going to right-click and choose Debug JUnit Test. Okay, and again, we'll give this just a moment to load. And with any luck, okay, let me pause as it gets ready. As I'm waiting for it to load, I realize I made a silly mistake, so we can certainly debug it, but I realize I did make a silly mistake that's going to be an easy fix. I created the plant. I did not add the plant to the collection. So here back in the plant DAO stub, I'm going to say all plants.add p, and that's why it failed. And save. Okay, now let's go back and let's run this guy again. Okay, so now I'm going to right-click and I'm going to choose Run As, Android JUnit Test. Sit back and relax for a moment, and let's see how we do. And I was right. This time the test passed. So you see what's interesting is while I was confident the last go that the test would pass, the test actually found a legitimate bug that I put in the stub. It caught something I legitimately forgot. And that's why I go back to the presentation where I say time, quality, and features. Pick any two. But one of the two you pick must be quality. And that's what this is all about. I can't overstate that enough. There is, I don't want to name names since this is going on YouTube, but there is a course management program we're probably familiar with. If you look at its reviews on the Google Play Store, the reviews are pretty bad for the first version. And then they made a second version, which was much, much better. And in the description for the second version, they pretty much apologize for the first version. But the problem is that you can't get rid of those bad reviews. And that's why I say, even if you have to scale down functionality, make quality a top priority. So next, let's see how we can extend this unit test to do more things. Now let's say that, for instance, if we have a valid plant to save, it should save. If we have An invalid plant, it should not save. And what I mean by an invalid plant, a valid plant should have a genus and species at the minimum. Hopefully a common name, but at the bare minimum should have a genus and species. So what I'm going to do is make a new test, and we're going to say test save, okay? And we'll say public void test save, and we are going to say plant p equals new plant, and then we're going to say plant p, let's say plant good plant equals new plant, and then we'll say good plant dot set genus, whoops, gensu, set genus, cercis, good plant, set species, cercis, and then good plant dot set common, redbud. And you know what? I'm sorry, I'm typing so quickly I realized I put the wrong species. It should be canadensis. Okay, and then we're going to say, what did we say? Plant DAO, save, plant P. Okay, good plant. There we go, like so. Okay. Now we know that if we save, we're going to need to wrap this in a try-catch block. I'll control 1, surround with try-catch. This is a good plant. This is a good plant. We should not see an exception. So we should not get here. I'm going to put fail here because if we get here, it's bad news. Now let's try bad plant. Plant, bad plant, equals new plant. Plant DAO, save, bad plant. This one we're expecting should not save because it doesn't meet any criteria. We put nothing in it, no genus, no species. So let's surround with try catch. Now here's what's interesting. In the catch block, we are expecting an exception. So we'll say assert true, true. We're just saying, yeah, okay, we should be here because we're expecting if we have bad data, it should not persist. Now here's a question for you. What if it does persist? Where should we put a fail message if it does persist? Where will it execute? Remember how a try-catch block works. As soon as an exception is thrown, it skips all lines until it sees the closing catch. So if I put a fail right here, it means that this save happened successfully and it did not throw an exception. We're expecting the save to not happen successfully. We're expecting that we should get an exception. So if we get here to this line, we're going to fail this test. So now we know as it is now that we don't have any guts of this stub in the save method yet, so we are expecting a failure of some kind until we actually create that. So let's go back and run our unit test, and let's watch what happens now before we fill in some guts of our unit test, before we fill in the guts of our method. Okay, let it go. I'll pause for just a second as it runs. Now, as we suspected, the test did fail. What's interesting here is take a look. Test fetch passed. Test save failed. Okay, so it shows us that since we've written multiple tests, one has failed, one has passed. Let's go ahead and try and make our save pass now. Okay, so this will be pretty straightforward. I'm going to control M, and I'm going to go to plant DAO stub, control M, and we're just going to dummy this up pretty quickly. We're going to say if plant.getGenus is not null, and that would honestly be enough, but we'll go ahead and keep going. Or plant.getSpecies is not null. Oh, okay, sorry. Is null. No, we want to see if they are null. We're gonna do the failure case first. If genus is null or species is null, then we're going to say throw exception, and we'll put in a message here that says throw new exception, and we'll put in a message here that says plant data are incomplete, and that's it. Otherwise, the else part is we have enough plant data to persist. Nothing to do. That's really all we need to do here. Let's save, Control M, and let's run this test again. So I go back, right click, debug, run as in JUnit test, and again I'll pause the video as it might take a moment. And take a look at what we have. We have success. So I've written a quick and dirty JUnit test here. We've seen that a JUnit test can verify that a program does what we want. We've seen that a JUnit test can also verify that a program meets our needs. So I will commit these up to our repository, up to our GitHub repository. And incidentally, if you look in the GitHub repository, if you take a look at IT 3048 assignment 1 logon page test, take a look at user DAO test, and you'll see that I have written here a fairly good sized test case for our programming assignment. We will switch the programming assignment a little bit. Instead of making a stub, what you will actually do is you will make the real SQLite implementation. But take a look. You see you have assert equals here, assert equals, and that is doing certain assertions that make sure our test does what it wants it to do. Now, one other thing to consider on this quality, time, and functionality paradigm is a test is only as good as what it tests. A test is only as good as what it tests. So what we want to see a lot of times is test coverage. Are we testing our program? Are we testing all of our program or just part of it? How much of our program is getting tested? I'm going to right click and I'm going to say, and this is a little bit off screen, let me, 1 second. I'm going to have to move the screen capture software, just a moment. Okay, now it might be a little easier to see. I'm going to right click and I'm going to say coverage and we're going to say JUnit test. What this will do is it will actually give us a report. It's very interesting. It will give us a report of how complete our coverage is. It's really interesting stuff. So 1 second here. Oh, here we go. Here's our coverage report. Take a look at the lower window here. So it actually runs the tests. Take a look at the lower window, and it's showing us that for plant places, it's showing us that we have 35.6% coverage of our source code so far. But part of that source code is generated, so let's not worry about that. If we go to the handcrafted source code, it shows us we have 42.4% coverage. I expand this and it shows us that the DTO package is 34.3% covered. The UI package is 0%, not a big surprise there. But take a look at this. Our DAO package, 95.6% covered. Now let's click on Plant Stub DAO and look at this. This is really cool stuff. It shows us what is covered with a test, okay? It shows us anything in green is covered with a unit test. Anything in yellow is an if test where it says some conditions are covered but not all. Okay, so you see the green stuff is covered. Now we get down to fetch plants by ID and take a look. That is not covered, so it's shown in red. So if you have a requirement to cover 100% or nearly 100% of your code, this plugin called EclEmma can give you a good view across your entire enterprise and show you what code coverage you have. So if you have the new person come along, we always say we want to do unit testing, but we always forget to. We always forget to do unit testing, and this is a good way to check the health of our application and figure out how much is covered in our unit test. So this is a plugin called EclEmma. If you go to, this is a plugin, which means it's an add-on to Eclipse. It is free. If you go to Help and then Install New Software, or in a newer Eclipse version, you can go to the Eclipse Marketplace. What you need to do is just look for the EclEmma program, and it will give you, let's see, I think I should have it here in my recent, because I installed it here somewhat recently. There we go, EclEmma. So, http://updateeclemma.org. that is the thing that will give you this right click and coverage as, and then that will give you this really cool bar chart that shows you what is covered and what is not covered, and then you can aggregate that and see the health of your application. So if you're interested in software development as a career, that's something to very seriously think about. Not only unit tests themselves, but also unit test coverage. Another thing we frequently forget to do is actually run the unit test. There is another plugin, and I don't know if I have this one installed here or not. I'm gonna take a look here. There's another plugin called JUnit Flux. There we go, JUnit Flux. JUnit Flux is really cool because you know that when you press save, it will do a quick compile of your program and put up the red squigglies. With JUnit Flux, it will also run all of the associated unit tests. So you get feedback immediately if your unit tests pass or fail. The value with unit tests is not just you writing them and you making sure that your program meets the requirements. And don't get me wrong, that is a big value. But the value of unit tests is also knowing if you're breaking something you don't know about. That's where unit tests are really, really powerful. And that's where JUnit Flux is nice, because as you save, you can see if you're unintentionally breaking something way far away in a different class. And when you get to very big programs, like my day job working in point of sale, um, that's something that's very important, because a lot of times you change something and you have no idea that other people are using it. So JUnit test, we have our test methods, we have our asserts, we have fail, we have EclEmma for code coverage. We know that JUnit tests can be used to make sure that we know what the requirements are to begin with. We write a prototype against those requirements, verify those requirements, and then finally our actual working program meets those requirements. And that's where we're going next. In our next set of lectures, which will probably be live again, we'll take a look at writing this all up in SQLite and then running these tests again to make sure that our SQLite program still works as expected. So thanks for joining me again. We'll see you next week.